Okay, so let's try to solve this nice arrays problem. This problem is named maximum profit. So basically there's a person here, it is named Mukesh. So he's running a business and he has a list profits he made in the last n days. Okay, so Mukesh wants to know what maximum profit he made in the few consecutive days. Okay, more precisely, he wants to know the maximum profit he made in any consecutive days in the range of A to B, both inclusive. You have to find the maximum profit Mukesh made in any consecutive days in the range of A to B. Okay, and we need to note that the profit of Mukesh business over n days is shown by array list profit. It may contain negative values as there will be loss on those days. And if the array is only full of negative values, then we have to return 0. Okay, simple. Now what I want to do is like to get sum of a array range from point, let's say A to B only. So what we can do is like we can get the cumulative sum of the array till position B and then subtract the cumulative sum of array just before position A. Okay, so we can do that. So let's make an array and we'll call it prefixes, and this will store the cumulative sum of arrays just before that index. Okay, so we are gonna have new int, and because we are gonna have just before that index, so the length of this array will be n plus 1. That will be one more than the total number of days, that's n. Okay, now we will run a for loop, and we will have integer I is equals to 0 to I less than n plus 1, and then we have I plus plus. Okay, sorry, I is from 1. We know that prefix 0, that's profit made profit made basically on day 0, if you say from day 1 2 3 4, or you can say just before first day, or you can say just before the 0th day, or whatever. If basically there's no profit made initially. Okay, that's 0. Now let's actually fix a terminology. So profit made on ith day is what's tell by prefix I tells us profit made on ith day, and days are of one index array. Okay, days start from 1 2 3 and up till n. Okay, and if we have said days start from 0 to n minus 1, then we would have said profit made before the ith day. Okay, so but we are following this terminology. So by this, profit made on the 0th day is 0. And now we are gonna go from this. We go to for loop, and now what we put is prefix of prefix on the ith day will be equal to prefix before that day and profit made on that day. Okay, so that will be profit. Now we have written a prefix function. Okay, now what we want to do is okay, so we are done. We can simply calculate the subarrays. We can do the brute force approach, and we can have an order of n square solution where we go from we try to form we try to get every single subarray which is possible in the range of having elements A from sizes A to B, and we try to put the max profit inside. But we are gonna follow another method. It's called a multi-set method, and what happens in this method is we create a multi-set, which is basically an array list. Okay, so we are having an array list of integer values, and we call it multi-set. Okay, and it is a new array list Now what happens is, in this array list, what we store, okay, this is used to store the possible starts, okay, store the possible start of the current subarray, okay, of store the possible starts, or basically the possible start of the current subarray. So basically, if you forget about this for a moment, look, what are we gonna do is like we're gonna loop through every point where a subarray can end. Okay, so every point where a subarray can end. So we will have a for loop. Okay, we will have integer and I. Where will I start from? I will start from index A, because like loop through every point, or every, you can say, every index in Prophet where a subarray can end. Okay, so basically a subarray can end at like the, okay, sorry, so yeah, basically we want like, what does I tells? I tells basically the index in Prophet where subarray ends, okay, or you can say it tells the, what does it else tell? It tells basically the ith day where or like per subarray ends, you can say it like that. Okay, so what is basically the, like, what's the basically index in Prophet basically where the subarray ends? What's the minimum possibility? So basically, if we start from the start and we go till like having the we can have like minimum a amount of like sorry, yeah, we can have like minimum a amount of okay, so I'm sorry, because instead of Prophet it will be prefix. Okay, loop through every index in like prefix where a subarray can end. So index in basically prefix, index in prefix where a subarray ends. Okay, so, or you can say ith day where a subarray ends. Okay, so basically I like on what day could be. So what are the days? Sorry. So what are the days where or like or subarray can end? Okay, so we can have like on 8th day, or we can have like 8 plus 1th day. Okay, so on these days until what? Till the nth day. Okay, so we will loop from A till I is like basically if you don't understand this, then it's fine. You just think of like the ith day where subarray ends. Okay, that's what I is. Now I goes from A and till N, and we increment I. So we got the like ith day where a subarray ends. Okay, so a subarray can end at the like ith day. Okay. Now if the subarray ends at the ith day, what happens is like what will be the start of it? Okay, what will be the like minimum possible start of it? Okay, minimum possible start is like of this subarray is at day, basically is at day A, basically I minus A. Okay, so if like I is equals to A, then it would be 0. Okay, it would be 0. So minimum possible like start will be basically you can say on day of I minus A plus 1. So we will be starting on the 1th day, and now we will be going through to the 8th day. Okay, so to get this profit, we need, what do we need? We need profit of I, okay, minus profit, sorry, prefix of I minus prefix, basically cumulative sum of till the ith day minus cumulative sum before the ith day. So that will be I minus A. Okay, it won't be plus 1 because we need to include like on the I minus A plus 1th day needs to be included. Okay, and you can say I minus A plus 1th day needs to be included. Actually, let's put it before, after this one. Now, basically we need to get this profit. This is basically the minimum possible start, and the maximum possible start will be like maximum possible start of this sub array. So basically we have this condition like necessary, when I mean by this sub array is equals to a sub array ending at ith day. Okay, so maximum possible start of this day, sorry, you can say this is the maximum possible start, minimum size, but maximum possible start. Maximum possible start of this subarray is that is this, and minimum possible start of this subarray is at day, what you can say is at day, basically you can say it's at like I minus B plus 1 comma 0, whatever is the like the maximum value, max of whatever is the maximum. Like if it's a negative value, then we take 0 basically. That's what my thought process is, because sorry, we take 1 basically. That's what my thought process is, because like we can't have like non-positive days. Days has to be positive. So you can say like days has to be positive. Okay. Now to do this, so what happens is like to get all the days between like between this one and this, and basically I minus A plus 1, we maintain basically an array list. Okay, we maintain the null set, okay, or array list for that purpose. Okay, so what are we going to do now? Okay, so let's look at from the starting. So I is equals to A at this point. Okay, so we need to have this basically we need to have this like the minimum possible start and the maximum possible start will be basically same. So basically the startings So the startings of like days from basically you can say from this day, okay, minimum possible day, and just before this maximum possible day. So before this maximum possible day would be like -2. Okay, so these days will also be needed by the I minus 1th, okay, will also be needed by the I minus 1th day. So we need to add the like maximum possible day and remove the extra days which are added by basically the previous day, by the I minus 1th day. Okay, so that will be, so what will be the extra day added by it? Extra day added by it would be like so one more minimum than our minimum, okay, which is basically -1, which is I minus b comma 1. Okay, and yes, we're done. Okay, now with this knowledge we are ready to go. So we need to, after that we need the best start from the possible start, and we can choose it like basically the which is equals to the minimum profit. The best start will be best start is equals to minimum profit. Best start has basically best start has the minimum profit, okay, because we need to subtract it. So whatever, like it's better if we subtract a lesser value. Okay, so let's do this. So basically if our I is like, so we need to remove this day. Okay, so we need to and remove the extra days which are added by ith day, which is like basically maximum of this and actually 0. You don't want to remove, like if the extra day which is like of that, or the minimum possible, basically the minimum possible start of the previous day is a negative. Okay, this means the basically the minimum possible start of would be 1. So that's why I don't have to do the max, like that's why we don't have to do that. So basically if I minus b is negative, so for that like we can just check, like we can just have an if. So if basically I is like greater than b, so I minus b would be positive. Okay, so if I is greater than b, then we just have to remove the minimum possible start of the previous day. So for that we can just have like we can just have mul set dot remove, and we give the integer value. So we can have the like integer of, and mul set, it stores basically profits. Okay, so stores the possible start, store the prefixes of the possible starts of the current subarray ending. Okay, so yeah, so we will remove integer of what? Integer of profit, prefix of what? Of the previous day. Okay, so like of the minimum possible start of the previous day. So minimum possible start of the previous day will be basically I minus 1th day. So for that, like, we will store, it will be the day will be this, like the day will be I minus, like b would be the starting, I minus b would be the starting day of that indicates the minimum, minimum possible start of the minimum possible start of I minus 1th ending subarray. Okay, but like this would be the starting day, but we need prefix I minus b minus 1 would be stored in null set. Okay, so we need to remove this I minus b minus 1. So we have to remove this integer. Okay, now we have to add basically the maximum possible start, because that would not have been added by the previous thing. So we have multi set dot add, and instead of adding, we can just we will have a function insert. Okay, that will help us to get the best start from the possible starts, and we will look at it later. You just for now just think of it like we are inserting or we are adding it. Okay, what are we adding? We can call insert, and it's not a function of this list, so we're gonna insert on the multi-set. Okay, and what are we going to insert? Like, we're going to insert prefix of this I minus a. Okay, so I minus a, and now we can have like integer minimum, you can say minimum possible, like, okay, what you can say is like minimum prefix. Prefix would be basically okay, this is insert. I'm sorry for the spelling. Now minimum prefix would be basically null set dot get 0. So we will insert it in a way such that the minimum prefix will be at the position 0. That will be the best start. And now what we are gonna do is like we're gonna have we got the best start, and now we have like integer profit, best profit. Okay, best profit of this subarray will be basically our prefix of I minus minimum prefix. Okay, and we can have like max profit. We'll have a function max profit. Okay, and I'm sorry for this. Max profit will be equals to some max profit. I'm sorry if we call this function itself. It's basically the again sorry. It has to be like the current best profit right now, and max profits like maximum value from both of them. And after doing this for loop, we can just return the max profit. I need to initialize the max profit function. So I'm gonna have like above here integer max profit is equals to 0. And now we need to have this, make this insert function. So private, is it static? It's static. Private static, it's void. Okay, I'm sorry. it doesn't return anything, it just changes in the null set. That's the array list. So function is named insert. Insert, and then we can have like array list of integer values as card mulset, and we're gonna have mulset, and then we're gonna have the value that's to be inserted. Okay, after having both of these things, we just need to insert it. Okay, so if mulset dot size, if the size of an array is like 0, then we don't need to check. We just have to add it to the array, and we can simply return from here. Okay, now if the size is not 0, so what we will do is like we have integer I equals to 0, I less than mulset dot size, and then we have I plus plus. Okay, now we are iterating over every index of the array. Now we check like if the mulset that get I, if this value is equals to value, then we can have like mulset dot add. We have index and then element, so our index will be I and the element will be value. Okay, now else if like, and we can now return. Okay, and we can have like if mulset dot get I is basically greater than our value. Okay, so we just do it like this. It's greater than equals to, then we can use it. Okay, and we can just basically add it at the end. Mulset dot add value, so we'll add it on the end and we are fine. Let's just try to run. Okay, so at line 56, I forgot this, and at line 60, what did I do? Okay, we have some integer value, and 60, and then prefix at 954. Okay, it's a runtime error. Tenth line. Profit of total profit of I minus 1, because it's minus 1 relation between fix and profit. Test case is passed. Now let's try to sample it. Thank you.